would like to welcome Nima Shokri to the podcast. Nima is the chair and professor of geohydroinformatics at Hamburg University of Technology and also the executive co-director of the United Nations University Hub that focuses on engineering and climate adaptation strategies. His work emphasizes AI and machine learning driven methods and algorithms and advanced modeling to analyze and predict factors that affect soil health. And Nima's done a lot of different things, but today I think we're just going to focus on soil health because he's very passionate about it and he wants to talk about it. So, and it's so fundamental to many different aspects. So Nima, I enjoyed visiting with you recently, and you were describing how soil health is so fundamental to food security, water resources, ecosystems, and managing climate extremes and addressing the sustainability development goals. Maybe you can define what you mean by soil health, and then also how it's linked to many of the UN sustainability development goals and all these other sectors.
Thank you for the introduction, and I would like just to thank for the opportunity, and it's a pleasure to be here to discuss with you about the importance of soil health. And that's the right question. What do we mean by soil health? And qualitatively speaking, you can refer to soil health as, I think that is USDA definition. That is that the soil health refers to the continued capacity of soil to function as an important element in ecosystem that sustain vegetation, humans, and animals. So that's the kind of a qualitative explanation of that. But when it comes to the quantitative explanation, what do you mean exactly by soil health? How can I compare, let's say, soil health in Texas compared to Hamburg? Give me a number. And then the discussion is much more complicated. And it's not surprising because you could as well consider soil health. You could define soil health as a function of the usage that you have in mind. What is healthy for application 1 may not be healthy for application 2. And so there is a rising interest. There's a rising interest to develop quantitative indices that enables us to understand, to quantify, to put a number on soil health on the different basically boundary conditions. You mentioned UN SDGs. Unfortunately, or I don't know, fortunately, there is no SDG dedicated to soil. There is no SDG dedicated to soil, but it's very difficult, or I would say it's even naive to think you can achieve SDGs without paying attention to your soil health. Some of them are quite straightforward to see the direct connection. Let's say SDG number 2, like zero hunger. That's, I guess, kind of obvious if you don't have healthy soil. So no, it will affect your food security, obviously. Or life on land. I believe that's SDG number 15. So these are obvious one. But less obvious one, for example, SDG number 8, when you talk about economic growth, right? Decent work and economic growth. So of course, many countries around the world, their economy, almost all countries actually, the agriculture is an important part of the economy, especially local economy and so on and so forth. So if your soil is not healthy, if you cannot produce if you cannot produce healthy crops, that obviously will affect the economic growth. And also it goes to let's say actually SDG 1, that is zero poverty, no poverty. Or for example, you talked about good health, SDG number 3, clean water, reduce inequality, for example. That's another one. Obviously, when the soil is not healthy, that will affect the farmers, that will affect the income, that will affect the GDP. That causes forced migration as well, forced migration. And we all know what's the consequence of those things. And in all of these topics, soil health is at the center of that. But unfortunately, you still see many people that when they call soil, they don't even call it soil; they call it dirt. You can my pants got dirty, right? While our very foundation depends on soil, and to me, when it comes to soil, compared to some other environmental topics, which are rightly covered properly in the media by public and all public awareness and all that, soil is utterly under represented, and so I think
Yeah.
interviews like that will contribute to this bigger goal.
Right, right. It's so foundational for many different sectors like food, water, ecosystems, and everything. But then that we don't really focus on it.
Yes.
Oftentimes, or the reporters don't focus on it. But I did see, just glancing at the news, we're always Googling stuff. But in the US, recently, they were reporting dust storms in the Midwest, in Illinois and Chicago. And they attributed to large storms, strong winds, loose topsoil, and dry farm fields. This was the National Weather Service. So I think, we think about the 30s dust storms and that, and we think we're done with it. We figured that out. We're okay, but really we have to be very vigilant and continuing, and we can't get, comfortable thinking that we have it sorted. And so I like your emphasis. It's a global issue, and also that we need to emphasize it. And when it's out of sight, out of mind, people kind of ignore it then, So, but, you mentioned when we discussed before what Roosevelt said way back when, and the Dust Bowl and the conditions then, and then the formation of the Soil Conservation Service. So oftentimes a huge environmental issue oftentimes leads to some positive action.
Absolutely, though that's absolutely. Dust storm is a perfect example of the why soil health matters. So to have dust, essentially, I mean, of course, there are many parameters affecting dust, but some of the key elements is you need loose soil, fine particles, so they can fly for a long time, for over a long distance. Sorry, not long time. Dry soil, not too much water in the soil, right? And a strong wind. And these elements, when they're together, then you will have you could potentially have basically dust. And the formation of dust storm is another kind of reminder for us that the soil health. You can't. I mean, in my opinion, this is my opinion. In my opinion, it requires global cooperation. Because you don't manage let's say in Spain, hypothetically speaking, let's say in Spain, you don't manage your soil properly. There will be lots of salt at the surface of the soil, deposited, salinization, and all that, right? And then when the dust storm comes, these saline particles can travel thousands of kilometers. So something happened, let's say in Spain, but people thousands of kilometers away, different countries, different places, different businesses even will be affected by those salty, essentially dust storms. And so it's very reductionist to think that we can solve these grand environmental challenges locally. Like we can't put a wall around the city so that the dust doesn't come, which is partly because of the unhealthy soil. So if you wanted to address these topics fundamentally, definitely it requires global cooperation. And yeah.
Right, right. And I guess, local action also, like in the Midwest, the Soil Conservation Service cover crops in the winter, so the soil isn't fallow, no-till agriculture, so that you're not loosening up the soil, and many of these other practices. So those people need to do that also, in addition to recognizing that many of the issues are global. And also, we talk about soil health, but also the linkage to human health, with the dust storms and everything, and a big impact on human health also.
I'm very happy you brought it up because under no means I didn't mean local decision doesn't play a role. Of course, but my point is that if locally you manage your soil, it doesn't mean you're safe because if the neighboring states or neighboring countries is not taking care of the soil, that you will be affected by the dust generated from the neighboring countries. So
Right.
definitely it requires local management coupled by some sort of international cooperation. It just doesn't work. I mean, physics is physics. It just doesn't work. The dust takes off, let's say, from I don't know Turkey, and it can go to Iran and the other way around. So you cannot manage it locally. However, obviously, if you do it internationally but not locally, that's the same problem. So it's really an interaction, there should be an organic interaction between local management and broader cooperation.
Right. And also, do you see a lot of linkage, or are you involved at all at linking it to human health, or do you interface with that at all, Nima?
Of course, on the topic of dust, we are actually heavily investing in dust in my institute in Hamburg with a couple of students and postdocs. And one element there is human health, actually. As you mentioned, when you inhale those dust, it can have like many, many consequences on your, ranging from uh, I read paper on that topic, so I believe it was Lancet. I'm not sure, but even there are some data suggesting that it may affect like the brain operation, the Alzheimer, and which is not surprising because if the dust is very very small, it joins the bloodstream and it can go places that it's not supposed to be there, and digestion, of course, the lung
Asthma and stuff like that.
yeah,
Yeah.
that's just the obvious one. But of course, there are less obvious one. For example, if the soil is a degraded soil, it's just more difficult to grow something. And not all countries on the US, they not all countries in the world, they have the technologies that are, let's say, practiced or utilized in US. And there are places that the everything is done manually, so it's just more tedious, more time consuming, more resource demanding to grow the crops in those areas, and that obviously will affect human health and economy.
Right.
Because when you affect the economy, obviously education will be affected, your health will be affected, food quality will be affected, mental health will be affected. So everything is kind of connected. So that's why the past few years I'm hoisting the banner that soil health matters, and we have to pay attention to that.
Right, right. And even that National Weather Service report was mentioning zero visibility, so driving,
Yep, there
and
you
that's
go.
probably one of the most dangerous things we do. So, much of my work focuses on water resources and soil, and the land surface is very important for water because, when you hit the land surface, then you partition the water into evapotranspiration with vegetation or runoff or recharge. And so a healthy soil then will be very important for water resources. Maybe you can describe that a little bit.
Absolutely. There is a very strong nexus between soil and water, I would say climate as well, because they're all connected. Let's say, for example, climate will affect soil through temperature, through soil moisture, right? Soil on the other hand, for example, soil affects vegetation, right? Soil affects the vegetation and the quality of the crops and all that. Vegetation will affect, let's say, climate and soil through evaporation, for example, or organic matter input, for example. Water is the same story. So when, let's say, there is precipitation and the runoff, the infiltration in soil, the groundwater recharge, all of these they are basically influenced by the structure of the soil, by how healthy is the soil. So to me, it's incomplete if we wanted to look into, let's say, climate, or let's say water resources, or let's say soil. The same story, soil. You only focus on that domain. I think you will not have a holistic view. You may come up with something that fix your issue like locally again, but since you're not considering the interaction between this element with the other element, I think the solution may not be sustainable. So there is a very strong, very deep connection between all these resources you mentioned: water, soil, climate, vegetation, and that's why I think some sort of a nexus approach must be utilized to study this phenomena.
Right, right. I think, Nima, one of the first jobs I had was related to radioactive waste disposal. We were looking for sites that had very almost no groundwater recharge because we wanted the aquifer to be protected. And so we got into looking at the soil zone and, is there recharge? Is there not recharge? And one of the key things that we saw was, if you have high chloride concentrations in the soil water, then that means that there's no recharge because, and so this chloride would in the southwest US in the Chihuahuan Desert in West Texas and New Mexico build up over, we could estimate over 10,000 years since the last glacial period. And so this was really good for radioactive waste disposal.
Yeah, yeah, yeah.
And so it moves us into the topic of salinity and your
Oh,
work
yeah.
and salinity. Sometimes, but a lot in many semi-arid areas, you have this buildup of salt because the vegetation is removing more water than is coming in, and so but that gives us tracks then the water movement and helps us define what's going on. And we also looked at. I was very surprised. You think in these desert regions. If you have like El Nino or you have heavy precipitation for a couple of years or something like that, that you would get a lot of water movement. But what seemed to happen was the vegetation just took off. You have these desert blooms, and then they zap all the water, and so there's no recharge. And so vegetation was very important even in these desert settings. We had weighing lysimeters and all sorts of things. So maybe you can describe your work on salinity, soil salinity.
Okay. So, I mean, soil salinity is a topic that what I do for a living essentially. So I've been working on that almost for 15 years. For 15 years. I've been working on salinity on different scales. And we are interested in processes at literally at nano scale. So we have like high resolution image. We go down there and like nano scale, micro scale, up to the global scale, up to the global scale. And so we wanted to understand the physics of the soil salinization and what basically causes solute transport and deposition in soil. But also on the other hand, we want as well to understand the extent of salinity globally and how it may react to different environmental changes in near and far future. And so I can, yeah, I mean, maybe I can just build up on what you said. So imagine you have like soil or like sand particle or glass bead. For example, this column, you pack it with sand or soil and add some salty water here. And you can do it actually in the kitchen yourself. I mean, I do it for my daughter. I did once an experiment with her. And so just leave the cup there for a few days and the water will evaporate, right? Naturally. So as water evaporates, the concentration of the salt increases. And after a certain concentration, crystal forms. And then you can see actually, which is very fascinating for children especially, that at the surface, you see the formation of a white kind of crust, and that is the precipitated salt. So water comes to the surface, evaporation occurs at the surface, and ions stay there. And then we did a lot of work on how different parameters, let's say particle size of the soil, let's say composition of that solution, let's say the atmospheric conditions, let's say properties of the particles, like how wettable they are, angularities of the particles, and structure of the soil. How do these parameters influence? It's just simple mechanisms I explained basically, and not only in terms of the salt the deposition and crystallization, but also how does that affect the evaporation process? How much water you lose because of the evaporation, and that's important because you wanted to close your water balance for the water balance for water cycle. You need an accurate estimation of the evaporative fluxes, and so we did a lot of small scale experiments and tests and modeling. And from synchrotron X-ray tomography to neutron radiography to laboratory experiments to understand the physics of this process. Okay, that's one part of the activity we did, and I can talk 5 hours about that. And the second scale for us was to look into the process globally. And so we generated uh, I believe, the first global map of the soil salinity under different climate scenarios in the near future and far future. And to do that, we utilized AI and big data analytics. And if you're interested, I can explain later on a bit more about that. And we generated maps of soil salinity globally with a high spatial resolution. An annual resolution, a high spatial and temporal resolution was 1 year globally. And interestingly, we have some studies as well. We show that what we learn at the smaller scale, because a lot of people ask, why do you do this smaller scale experiment? You go, to National Aragon Lab in Chicago, you run this massive, expensive experiment, and you have a couple of grains next to each other and look into the, I don't know, transport of salt through among these 5 grains. What's the point of that if you are talking about soil salinization, which is a global problem, and so on and so forth? And interestingly, in some of our work, we see that what we learn at the poorer scale, what we learn at the smaller scale, when we understand the physics, when we understand the process, what is the governing mechanisms, then we can explain the global responses. We go to the global data set and we apply the knowledge we obtained from the smaller scale experiment, and we see that using that physics, using that process, we can actually describe what is happening globally, which is always encouraging to show we can cross across scales. And yeah, so I hope I answered your question.
Oh yeah, so that was fascinating, and I really enjoyed watching the YouTube video. You had a YouTube presentation of the synchrotron
Correct.
experiments, and I thought they were fascinating. And
thank you.
I jumped from I did my PhD in karst carbonate karst systems, and then my first job was unsaturated zone hydrology. So
Okay.
without Google or without any search engines or whatever, I had to learn. And most of it was phone calls with experts. But
Oh my
I
God.
thought those images were incredible. And you could see at the pore scale, that the air invades. And so the large pores are filled with air, and then the water is at the soil connections. And you looked at sand and you compared with clay, and you saw those wet areas develop and more widespread in the clay, and then you saw the evaporation related and the higher concentration then in the
Across the
sand.
surface.
And I
Correct.
really enjoyed, you did an experiment looking at the depth, 1 meter or 2 meter of a water
Yes.
table. And,
Wow,
and
I see that you really you looked into my work and watched
Yeah,
the video. That's
because
correct.
I mean we want to know, what does what does soil texture have to do with salinization? What does water table depth have to do? What does climate and the demand for the water have to do with these? And then, as you say, then you were able to link that to
Yeah.
your global mapping, which was incredible. And
Thank
so,
you.
because sometimes we oftentimes diss people who do these very detailed experiments. Oh, that has no relevance, no applicability. Nobody will ever use your results or whatever. And it's kind of difficult to keep going. But you very nicely linked those synchrotron experiments, those very detailed XRT data, to help you understand and develop and predict. And you're correct. I was looking long time ago for global maps of soil salinization, and I think I had Gaussian data and things like that. But you show how your global maps greatly improved, on Food and Agricultural Organization maps or any other groups that were trying to put stuff out there. So kudos to you for doing
Oh,
that.
thank you. Thank you. In fact, FAO released I believe it was December 2024, they released the global assessment of soil salinization. And in their report, they used some of the figures we had in those papers to show basically the global map of the salinization. What you mentioned about different parameters is really to the point that, for example, when you talk about climate, or let's say weather, right? Let's say it's temperature. When the temperature changes, you affect the evaporation. And just simple experiment I explained here, when you affect the evaporation, the velocity at which these ions are transported through the soil profile will be modified. And what is the soil salinization? It's essentially the excess accumulation of salt in the soil, right? So then you will have more salt. Or the water table is a very interesting aspect here, that depending on the texture of the soil, whether it is fine texture, coarse texture, the water table may reach to the surface, or it may wet above the water table up to a certain depth below the soil surface, right? And so if the water table is brackish, if there is salt in the water table, so that salt will be transported through the soil profile. So it's a combination of the depth of the water table, the soil texture, and many other parameters, climatic parameters, parent material. And these are, by the way, all of them are kind of let's call it natural kind of parameters. Another important parameter is anthropogenic activities, human-related activities, that, let's say, if you don't have a proper irrigation practices in place, or if the quality of the water that you use for the irrigation of your soil is low, right, or is salty water, that will obviously impact the soil salinization. So I remember one of the earlier paper I think we published in 2020, where we didn't talk about future, but the current status of the soil salinization globally. That was, I think it was invented to PNAS. Back then, we listed 43 different parameters that could potentially impact the soil salinization. And with AI, we could kind of build a model relating the soil salinity to these 43 different parameters, and we map the salinity and so on and so forth. Yeah.
Right. And, many regions, for example, Australia, they had a big problem with soil salinity issues. Because when they developed agriculture way back in the 1900s, they were replacing eucalyptus vegetation, deep-rooted vegetation with crops, and then they had fallow periods. So they increased the recharge, then the water table rose to the land surface, and they had dry land salinity. And then I was just interviewing Azim Shah recently in Pakistan. So they were using a lot of surface water irrigation and then waterlogging and then salinization, and then they switched to groundwater, So there's no free lunch. It seems like wherever you turn, but it's managing the trade-offs.
And that actually that indicates, or that reflects on the complexity of this problem. It's really a complex problem. And that's why for many of the questions that we don't have the answer, because it's just so complicated. Sometimes you feel or you think, okay, I know how to solve this one, or I found the solution. But then you see, okay, yeah, you fix this part, but another part is now a new problem. And so this is the nature of this soil. Soil is a very complex system, as simple as this. It's just a very complex system.
Right.
Let alone, we didn't talk at all about, let's say, biodiversity, for example, that affect the salinity level. And everything is basically connected when it comes to soil and soil health and salinity.
Right. So, you do a lot of artificial intelligence, machine learning, and that's what you use then to try to develop this global map. And it's an extremely powerful approach. And you mentioned 43 variables that you threw at it. And it's nice that you can, with AI, you can throw the kitchen sink in there, and then let it rank things and give you an understanding. Then you have training data and validation. Maybe you can describe the methodology, because I think that's very important for people to understand.
Yeah, absolutely. I mean, so what AI offers in this context is that that is my opinion. So I'm normally wrong, by the way. So it's my opinion.
Me too.
Yeah. So with AI, we can consider, we can quantify the impact of many more parameters that was previously possible by, let's say, mechanistic approaches, because you need to develop the equation. Let's say how, I don't know, price of tomato influences the soil salinization in Altusland in Hamburg, hypothetically speaking. But what equation you wanted to use for that, right? And there is not enough data to build what's the physics behind that, what's the chemistry behind that. But we know that may impact that. Possibly, if I don't know, I mean, I don't want to get into how the model can affect salinity. So the AI, what AI offers is that you can include you could consider many more parameters in describing the phenomena that you're interested. So in the case of salinity, of course, the backbone of this type of calculation is data. You need, and your model is as good as your data. If your data is low quality, the model prediction is not that useful. But if you have high quality data, so in this particular paper, that the current state of the salinity, so we had thousands of data points using different global databases, WOSIS and other places, that for a given spot, they measured salinity for a given spot. And then in those, let's say, I believe we had about 200,000 points. I believe we had about 200,000 points globally. So on that 200,000 point, then we go and we identified like 43 different environmental parameters. Whatever you wanted to name it, you just name it. It was there. And for this 200,000 point, we went and we identified, we quantified, we measured not we measured, but we had the data. Some of them were measurements, some of them were from satellite remote sensing, and so on and so forth. So for 200,000 spot, we have 43 parameters for every spot. And then you make a massive table, essentially. Let's call your salinity predictor. That is, the target parameter. That is your target. You wanted to predict the salinity. So one column is your salinity in that 200,000 spot. And then 43 other parameters, columns are those environmental parameters. It could be temperature, could be precipitation, vegetation, slope, clay content, sand content, you just name it, right? And then so I have 200,000 points, I have the salinity, and on those points, I have 43 different parameters. So here the assumption is that this collection of parameters, they can describe the observed salinity. And then you expose, and you expose this table, this large number, large table to an AI algorithm, and you force the algorithm to find the relationship relating your target parameter to the predictors. Okay, and then you do testing, you do validation. And then if you are happy with the validation, so normally what we do is like a certain portion of the certain fraction of the data, we don't introduce it to the algorithm. So the machine does not see that data. Let's say we put 20% away. The model is trained based on that the 80% data that is left. And then I use this model to describe that 20% that the model did not see before. Okay, so when you're happy with the quality of your prediction, and then so I have this measurement on 200,000 spots in the world, right? But many areas in the world, I don't have the measurement. So what I do, I go to every spot, depending on the resolution that you have. In that particular paper, it was kilometer scale. So every kilometer by kilometer in the world, we identify that 43 parameters that we have from satellite, we have from this, we have from that. And then we have these 43 parameters, we put it in our kind of equation or model, and then we get the value of the salinity. So I have the salinity of that particular spot, and then I do it pixel by pixel, and then I can get the map of salinity. And when we wanted to predict the future, what we did was that so we learned a little bit more about the process. So in our next paper, when it was 2021. There, when we talked about the near future and far future salinity, we reduced, as you mentioned, when we had 43 parameters, we realized some of them are not that, doesn't have such an impact on salinity. So we got smarter a little bit. And then in the next study, we reduced the parameters to, I believe, 14 parameters. And out of these 14 parameters, 5 parameters were kind of climate-related parameters or time-dependent parameters. 9 were like other things, but 5, let's say, for example, if I remember correctly, let's say evaporation, or let's say, I don't know, temperature, stuff like this. And then for these parameters, I have the future prediction. So I assume, let's say soil texture, I assume doesn't change. I assume, okay, soil texture doesn't change, but temperature may change. But since for temperature, there are climate models predicting the future, so I use those parameters into the trained model to show me how, let's say, salinity may change on the different climate scenarios. That's how we did it.
Right, right. So it was very interesting, and it's great that you were able to collate all those data. And we have so many different data sets now: remote sensing, measurements, a model output, and all sorts of things. And we're increasingly being forced to look at all of it. And so this is a way to do that. And so that was fascinating. And I noticed you had a lot of zeros, so you turned it into a binary data. Is it saline or is it not? And you picked a threshold conductivity then to represent that. And so, and then maybe, I don't know, is the map really a probabilistic output, or is it of the salinity, or do you have uncertainty estimates with the map?
So in that particular paper you are talking about, if I remember correctly, I think we did not have the, let's say, map of a standard deviation of these predictions. But in our current work that we are doing, we actually just finished this paper we submitted last week. There we actually included, so we generated the map with a different resolution and different focus, and all of those maps came with the corresponding, let's say, a standard deviation for every pixels and the uncertainty, how replicable is data, and so on and so forth. So you mentioned the threshold, that 4 decibels per meter. That was a very important number because that is what you say. Then you label the land, you're saline and you're not saline land, and that is as well another open topic, open question in the community, that what is a saline soil? I mean, what should be the salinity level? And in that paper we have a paragraph we actually discuss about that different organization, they have different threshold. So FAO has one threshold. I don't know, other organizations have other threshold, and they vary quite a lot actually. And so this is a kind of I would say certainly an open question, and that can benefit many. That if we can come up with a less subjective way to say this is saline and this is not saline. And I think part of the difficulty, or if you want to call it confusion, or I don't know, is because it really partly depends on your application as well. It depends.
Right.
You're running a vineyard or you are running a potato farm. And that adds to the complexity of the problem.
Right.
Use.
Yeah. But so, Nima, when I was looking at the map of the data that you had to develop the global map, you can see very high density of data in the US and in Europe and everything, and then zip in a lot of places. So It's really nice that you can develop these predictive skills then where you have the data and then apply them to other regions. And, it may be that some places don't share the data or whatever, but this is really powerful then. It's really nice to see a global map. And then also, where did you find the biggest issues with salinity? That would be interesting.
If I may, I'd like to comment on the data point you mentioned. It is very correct that some places, not a few places in the world, a lot of data, like US certainly, Europe as well, because of this Lucas campaign we have, but many areas in the world, they don't have data, or they don't release the data, whatever. And you're right, this AI now enables us to basically, we train our model using thousands and thousands of data points, and then we can use this model to predict, let's say, salinity in Iran, for example, or in the Middle East. But one kind of potential limitation is that whether or not we like, so the model might be biased toward those data, because the models are trained using those data. So of course there are ways to deal with that, and we always do that. But obviously the reliability of the models, the reliability of the prediction would be significantly enhanced if we have a fairer distribution of the data globally. So if we have proper, adequate number of data points from Africa, from Asia, from other places, and then we run the model using all these data points, I think that is very important. Your second part of the question,
Where is the
yeah.
salinity? Where did you find the biggest problems with salinity from the global analysis?
Exactly. So I wish my paper was in front of me, but I believe places like China, places like Iran, places like I think even Saudi Arabia, these places, a lot of places in arid and semi-arid area mainly, basically, a lot of them were there. But also there are, for example, look at USA, California. I do remember. I think I had just. It takes me 5 seconds to check. The paper was published 5 years ago, but I think California, for example, stood out in the map. I remember that. And but Middle East was very much affected. Middle East was very much affected. MENA region was quite affected. North Africa, Middle East, and places like part of Australia, as you mentioned, part of Australia certainly actually that was one of the affected areas. Yeah.
Right, right. I really enjoyed your Forbes article.
Oh yeah.
And the quote in there, unlike people, dust particles require no visa to cross international borders. They can travel effortlessly thousands of kilometers from one country to another. And then, emphasizing that the transboundary issue, in need of serious global cooperation. So maybe you can describe that a little bit. And then just last month in June, NOAA reported Saharan dust moving across the Atlantic to the US, and they were tracking by satellites the Saharan air layer. So maybe you can describe your Forbes article. I couldn't read the whole thing because I didn't have access, but
I'm sorry about that, but absolutely. I mean, this is really the core of the my point that I'm trying to promote in different platforms and different forums that I join. That these problems are really, I think it's misleading if we focus only locally. This will not do the job. We might be able to locally for temporary solve the issue, but if the issue, let's say, persist in neighboring countries, neighboring states, so there are so many environmental events may happen that causes the transport of those stressors to your region that is very well kept. Let's say, unfortunately, I hear the news from US regarding the flood, the ongoing flood, and I'm very sorry about that. But have you thought about the effect of such flooding on the spread of the salinity across thousands of kilometers or hundreds of kilometers? Because all this flash flood essentially they wash out all the salt that is from location A and bring it far away from, like, it could even go to other cities, other states, other or the dust, as you mentioned, that so it's let's say that you have a saline lake, and saline lake is shrinking, and then there are lots of salty particles in the bed of that lake, right? And then the dust comes. So the saline lake might be shrinking because of local mismanagement, because of construction of too many dams, because of maybe expansion of, I don't know, the cropland, maybe climate, actually, the change in the climate, changing the precipitation patterns. For whatever reason, this is shrinking. And then when the wind comes and then when the soil is dry, so these salt particles, they just go to different countries. We have actually simulation of that process. A number of years ago, we had a paper where we showed that these dust particles, salty dust particles, saline dust particles, they crosses countries within 24 hours. And that was not an AI-based calculation. It was a mechanistic or process-based simulation that we showed that if in this particular kind of a spot, if there is this particular, let's say, a storm occurs, which had the precedent. Like in 2018, we had that storm. We said if the same storms happen again, this salty dust can go thousands of kilometers. And that's when I said that, yeah, they don't apply for the visa. They just cross the boundaries. They just cross the boundaries. And that is valid almost for all environmental problems. So let's say groundwater contamination. So it's not like they, Austria, and then they stop at German border and then they communicate with the German authority. It doesn't work like that. So the contaminated groundwater just come in, right? So this is why I think it would be great. I know it sounds extremely challenging, possibly probably I don't know, close to impossible. If we could establish a dialogue among nations, and there's a common interest because everybody likes to live in a healthy environment. As long as you're a sane person, you prefer to have a clean water, clean air, clean soil, and so if we could establish an international dialogue to promote global cooperation around some of these environmental problems, I think that is an absolute necessity to fundamentally address these challenges. I'm not downgrading or not downgrading, understating. I'm not understating the importance of the local management. Of course, the local. If you don't care about your soil, obviously you lose the quality of your soil. But I'm saying that if you take care of your soil, but others don't, it does not necessarily mean since you're taking care of your soil, it does not necessarily mean you're safe. It doesn't work like
Right,
that. Environmental
right.
problem, they're interconnected and they're transboundary issues.
Yeah, yeah. I think the local management is a necessary but not sufficient condition.
That's exactly what I wanted to say. Yes.
Right, right. And you mentioned President Roosevelt way back in the 30s, even saying the nation that destroys its soil destroys itself. And when we were recovering from the Dust Bowl, and then oftentimes when we have a big issue like that, we have action happen, and we end up being stronger after it. So the Soil Conservation Service formed in the mid 30s, and so we oftentimes a disaster can promote a positive action and help us improve conditions.
That's true. I think that is the positive side of that, and I agree with that. I think we should learn from all these experiences, and hopefully that will help us, that will enable us to come up with more robust approaches and reliable modeling and results and tools and to basically protect us as well as ecosystem. We are part of that. They protect the human animals ecosystem against all these uncertainties, all these future uncertainties, be it climate or be it anything else. I think
Right, right.
creating this sense of, yeah, I think that's what I wanted to say, creating this sense of urgency that we need to care about our soil. What breaks my heart is that, as I said, I mean, I heard this discussion about soil health, and it's just like surprising why there are so much little said about the importance of soil, while on daily basis, almost on daily basis, you're dealing with soil health. Because did you have breakfast today? Did you have lunch? Did you have dinner? So most likely that food that you had was from soil. End of the story. And it's very funny that how for granted we get soil and how fragile is that. So it takes. Don't quote me on the actually. It's gonna be the video gonna be on YouTube. But yeah, but I don't have the reference at the moment, but I think I read once, I might be wrong, but I think I read once that it takes about 1,000 years to make about a centimeter of soil. I
Right.
can Google that and
Yeah, yeah.
I think
I saw
something like,
that too. Yeah, right.
yeah,
It takes
something,
a
right? Yeah,
long
thousand.
time.
Yeah,
Yeah,
long. Let's agree on the long term. It takes long time to create a little bit of soil, but it literally takes 1 hour to destroy it. You just go down and add a very, very hazardous contaminant to the soil, and the soil just loses its its function,
right, right.
and
And
so
and
it.
I think, Nima, I think soil carbon and soil organic matter is so important. And so if you improve that, then you have so many co-benefits. So I mean, some people say, well, we need water for irrigation, for crop production in semi-arid regions, but just providing the water alone is not sufficient. You need the nutrients, and if you have good soil carbon. And so the co-benefits of improving soil health are enormous. And I think if
Absolutely.
people realize that, then, we would emphasize it more.
Absolutely. I mean, Carbon, for example, nowadays everybody or a good portion of they like climate. They like climate. They talk about CO2 and all this stuff. But I don't know how many of the or how many people they know that the amount of the carbon that is stored in soil is massively more, like massively more than the amount of the carbon that is in the atmosphere. So imagine if the soil is degraded, if this carbon is released to the atmosphere, that's basically the game over. It's like literally speaking. So the soil is the when it comes to carbon sequestration, soil plays an important role. So as you said, there's lots of co-benefit here, and that's why you need like some sort of nexus approach. So climate affects soil, but soil as well affect climate. And carbon that you mentioned is a perfect example of that. Only if the people understand that there is no need to have isolated topic of climate, isolated topic of soil. It's actually massively deeply, heavily interconnected.
Right, right. And Nima, you are part of this new program in Europe called AI for
Oh
Soil
yeah.
Health. And that's a big project, I think about $13 million. Maybe you can describe a little bit of what the goals of that project are.
Sure. Of course, sure. Yeah, that's like a flagship project at the European Union level. That's called something called like a mission call AI for soil health. So the idea essentially is to develop to digitalize the European soil, and we aim to kind of develop a kind essentially an app that with a very high resolution. 30 meter, every 30 meter across Europe. Yeah, it's 30 meter across Europe using AI and many other approaches, modeling tools to give information about soil health across Europe and see how different parameters affect soil health and also quantify soil health, producing new indices, how to basically compare the soil health in Romania compared to, let's say, I don't know, in Poland or in Germany, and with a very high resolution. And so that's the idea. And in that project, so we are active in a number of topics, but my main contribution is about soil salinity, obviously, and soil degradation. And also we produce educational materials aimed at, I would say, general public, but definitely they are useful as well for a bachelor student, master student, as well as teacher. Who they, for example, I know my team just today sent me. Now they produce one of the videos on bulk density. And they go to the field, they explain what is bulk density, they show how to measure that, they show the devices, 3 4 minute video. So I am producing some educational material in that project together with the map of soil salinity across Europe and soil degradation.
Right.
I just wanted to say, sorry, that it's a very large project. So I think like 25 plus European organizations and institutions are involved. So it's not only me getting that. The project has a lot of partners. And so I think like 27 EU institutions are involved. And I am only one of them.
Well, that's wonderful. That would be an incredible resource. And one last thing that I would like to talk with you about is this United Nations Sustainability Nexus, Analytics, Informatics and Data, AID. And you have one part of that that's focused on the Soil Health Forum, how what data are available, the machine learning approaches that can be used, and of course your salinity, nutrients, carbon, and the global models and monitoring approaches. So I really like that, and I like that short piece that you wrote, describing it, and that's a great initiative. And
yeah, I mean that 8 program, analytic, informatic, and data. So there are several modules there. So I lead the soil health module of that, and so the idea is basically, as you mentioned, I guess that there are so much data and different tools flying around different countries, different groups. So the idea of this soil health module is that to become the destination for data and tools related to soil health characterization. So let's say you are new in this business, you wanted to start your PhD or your company or your policy brief or whatever, you wanted to get some data. So we wanted to have all these different data sets from all around the world, as much as we can, be centralized, that we put everything there, and that we believe will be a big help for modelers, for practitioners, for farmers, for policymakers. And so that's the idea, to make these tools available to many.
Right. Well, thank you so much, Nima. You know, I jumped ship to work on soils a lot early in my career, and I must say that the community, the soil community, Peter Warenga from Holland and from the Netherlands, and Rien van Genucht and everything, and Glendon Gee, they were all so helpful to me. It was phone calls and taking notes, but they really helped me with that process, and they were so really appreciate it. I think the community is very open and very helpful, and I really admire a lot of the work that you're doing. And I will release also highlights of this podcast with links to your papers or to YouTube videos and things like that, so that the listeners can access more information. So just to summarize, Nima Shokri is the chair and professor of geohydroinformatics at Hamburg University of Technology. Thanks a lot, Nima, and good luck with your research.
Thank you. It was an absolute pleasure. Thank you. Bye.